Hello everyone, this is Cameron Snow with Danomics.com. In this video, I'm going to be demonstrating Danomics' new log editing capabilities. So, let's get started. I have my CPI file open and I have some wells loaded. And what I'll show you here is that we have multiple gamma rays for this particular well. And some of these gamma rays are on a different scale, some of them need to be depth shifted. And I'm going to show you how we can correct that using the new log editing module. So to get to the editing module, come here to the central drop-down menu and select editing. This will bring up an automatically generated series of plots where you'll have all the available curves displayed. You'll have a track here in the center that'll show any modifications to the curve, and then you'll have the final composited curve shown here on the right hand side. Now you'll be able to select this for any of the curves, but in this particular well I only have a gamma ray that's been digitized. So when we look at this well, there are a number of things that we can see. First of all, there are curves that are apparently on a different scale, or at least it appears that way. And so maybe what I would like to do is I would like to stretch and squeeze one of these logs to match the other. In this case, I'm going to stretch the GR1 to match the SGRDD. To do this, I can choose scaling, and I'll say custom. And here in the GR1, I can apply scaling. So here I'm going to put in a gradient. This will stretch the curve. And you can see now that we have done this, the blue curve here in the center track has responded. And instead of being significantly lower than the red curve, the value range is now similar. You'll notice that I may need to reduce its overall value here. I can do this by setting the intercept, and I'm going to put a value of -10. This gives us an excellent fit now between the red curve and the blue curve. So that's how we can use scaling to make data align better before compositing happens. So if we zoom back out, I see there is some data up here shallow in the log, and so I'm going to zoom in here. And what you'll notice is that when this was digitized, apparently the depth tracks became misaligned. So let's see if we can correct this. So when I hover over here on the left-hand track, I can see that the curves that are being affected are the GRR1 and the GRD curves. So since I only have one file here and I'm only have the gamma ray curves, I'm going to select shifting curve by curve. And what I will do is I will look at that GRR1, and I see that the depth needs to be shifted by about 8 feet here, and it needs to be moved up. So I'm going to say -8 here for the GRR1, and we'll see that it has been shifted up. And I'm going to do the same for the GRD. Watch here in the center track to see the response. It also needs to be moved up by about 8 feet. Now we can see that we have aligned all the peaks here. Okay, so now that we've done that and we have a better match, one thing we may want to consider is the splice order that we would like to use. So perhaps if I'm uncertain of whether or not some curves should be included, maybe I would like to omit them. Now these curves are in my alias table, and therefore by default they would be used in the compositing, and they'd be used in the order shown here. Let's say I wanted to customize this. I can click on the custom button, and let's say I only wanted to take the curves such as GR, GR1, GRR, and GRR_1. So now that I've done this, I'm taking a more limited set of the curves and I'm taking them in a specific order, which is resulting in my final composited curve. Now perhaps when we look at this, we can see some curves that are significantly higher in value. We can start to see some spikes in the data that we may believe are not representative of what we'd like our data to be. For example, here I have one spike that is significantly higher. There are a few ways that I could address this. For example, I could use null depth ranges. I could look at this curve GRR underscore 1, and I could say that it needs to be nulled in between the depth ranges of 2783 and 2789. So I could type this in here. And now on the results track, we see that that spike has disappeared. I actually made a slight typo there. Okay, now we see that that spike has disappeared, but we still have the original curve. That's one way that we could do this. Another way that we could do it is we could filter the data. So let's say I wanted to eliminate all the data that was greater than a certain value. So I could filter data to only display certain things. So I could say curve less than or equal to, and let's say 150 in this case. Now you'll notice that we've filtered this curve to only show data that is less than 150. Okay, so that is it for this quick tutorial. But just as a reminder, there are a few operations that we did, so let's walk through those one more time. First of all, we did some scaling of our data to align it, and we set the intercept, which is shifts your data either to lower values or higher values. We set a gradient that's greater than 1 will stretch your data, and a gradient that's less than 1 will squeeze your data range. We perform depth shifting on 2 of the curves, where negative values shift curves up and positive values shift curves down. And then we looked at a few different ways to remove bad data. So we can either filter the data to meet a series of criteria, or we can null by specific depth ranges. And then finally, we set a custom splice order that is different than that of our default alias table. Now, it's important to note that these type of operations only occur on one well. Even if you do this on your key well, it only applies to that particular well. And that's because this type of editing is single well editing. It's something that should only be done on a single well. One thing to keep in mind is that in this case we did shifting curve by curve, and that's because this well that we're looking at only had multiple gamma rays that were digitized. So there were no other curves that could possibly need shifting. If you have multiple files, let's say run 1 and run 2 from your well being logged, you would probably want to do shifting file by file, in which case you would take a reference curve like your gamma ray, and you would shift the gamma ray from file 1 to match the gamma ray from file 2, and then all the curves in file 2 would be shifted relative to file 1. All right, if you have any questions, please let me know. You can always reach us at support@danomics.com. Thank you.